Hello friends, myself Dr. Nirav Singhal and our today's topic is ozonolysis. In ozonolysis, it is used to predict the number of pi bond present in an organic compound. Position of pi bond in an organic compound can also be determined based on ozonolysis. Alkene and alkyne can show this reaction. Here, ozonolysis is all about making and breaking of foam. Alkene on ozonolysis gives alcohol, aldehyde, ketones and carboxylic acid, whereas alkyne on ozonolysis gives diketones. Chemical reaction of ozonolysis. Under this chemical reaction, any alkene group of compound on ozonolysis gives ozone as an intermediate. Whatever ozonide obtained as an intermediate, there are two possibilities. Either this ozonide react with zinc and H2O and gives both aldehyde as a product, RC11OH. Here this breaking of bond is take place and this breaking of bond is responsible for the reaction. Or instead of zinc and H2O, if you use hydrogen peroxide, KMnO4, H plus and heating, it gives carboxylic acid as an product. Yes, this reaction was not given in an NCERT book, but if you go through the many of the papers, you may find that there are so many number of reactions based on this. Symmetrical alkene on ozonolysis gives two same aldehyde or carboxylic acid as a product. Whenever symmetrical alkene undergo the ozonolysis, it gives two similar aldehyde or carboxylic as a product, whereas asymmetrical alkene on ozonolysis gives two different aldehyde or ketone as a product. Next, the most important point which may be asked in the examination, number of product for open chain alkene. If your alkene is open chain like butene, butene, propene, ethene, pentene, etc., then acyclic alkene or open chain alkene on ozonolysis gives number of products is equal to number of pi bonds plus 1. Suppose butene, it has only one pi bond, so you will get two different products. If butene, then it is only one pi bond, then two products. Buta-1,3-diene, it is a 2 pi bond, then you will get 3 products. Penta-1,3-diene, 2 pi bonds, then you will get 3 products. Hexa-1,3,5-triene, here 3 pi bonds, the number of products on ozonolysis will be number of pi bond plus 1. Very good. So it will be 4. Now, in case of cyclic alkene, on ozonolysis, it gives number of product is equal to number of pi bond. Suppose only 1 pi bond, then it has give only 1 product. 2 pi bonds, then it will give 2 product. 3 pi bonds, then it may give 3 products. Yes, dear students, you have to remember that number of product is equal to number of pi bond. Now, let us study one by one with detail. First, we will consider the example of butene. Butene is an asymmetrical alkene. This symmetrical alkene on ozonolysis gives but-2-triozonide as an intermediate. Here this pi bond present in that, this pi bond undergo the breakdown and gives two different products. Now butane triozonolides, if it react with zinc and H2O, the bond is breakdown as shown in the diagram. These dotted lines, these two dotted lines, this indicate that the bond is breakdown from here and CH3C11OH, ethanol as a product. Here both the product are same because it is symmetrical alkene, but instead of zinc and H2O, if you utilize hydrogen peroxide which act as a oxidizing agent, this is called as oxidative workup. This is called as oxidative workup. Or KMnO4 and H plus on heating, then it gives, instead of aldehyde, all of these are oxidizing agent and aldehyde on oxidation gives carboxylic acid. So instead of ethanol, ethanoic acid is obtained as a product. This is about symmetrical alkene. Whenever symmetrical alkene react, it gives two similar aldehyde or carboxylic acid as a product or ketone also. Now take us to consider the example of butene. But1 is a asymmetrical alkene, and if it's undergo the ozonolysis, wherever the pi bond is present, at that position make the bond, and here you can obtain but1 in triozonide as an intermediate. This ozonide as an intermediate on hydrolysis with zinc and H2O, you can found CH3, CH2, CH double bond O. Here first three, propanol, and the last two, methanol as a product. But if instead of zinc and H2O, if we use H2O2, KMnO4 and H plus as a heating, then we will get propanoic acid and methanoic acid as a product. Because it is an asymmetrical alkene, it gives two different products. So we will again go through the fact that symmetrical alkene on ozonolysis gives two same products, same aldehyde or carboxylic acid product, whereas asymmetrical alkene on ozonolysis gives two different aldehyde or ketone as a product. Now, second, number of product for open chain alkene is number of pi bond plus 1. You can observe. But2 is an open chain alkene. So it is a symmetrical alkene and open chain or acyclic alkene. So on ozonolysis, 2 aldehyde ethanol plus ethanol or ethanoic acid plus ethanoic acid, two products. Here again, asymmetrical alkene on ozonolysis gives two different and two again. But let us consider the example, one more example of asymmetrical alkene. Here this asymmetrical alkene on ozonolysis gives but2 and propanone as a product. Here two different ketone observed as a product. Here again only one pi bond is present. Let us consider the example of cyclobutene. This cyclobutene on ozonolysis gives cyclobutene triozonide as an intermediate, in which on hydrolysis with zinc and H plus, this pi bond is get breakdown from this point, and we will get butane 1,4-diol as a product, CH3, CH double bond O, CH2, C double bond OH. Clear? Only one product because it is a cyclic alkene. Cyclic alkene, like if we consider the benzene on ozonolysis, benzene has how many pi bonds? 3. So how many products will be expected on ozonolysis? 3. Yes, 3 mole of glyoxal CHO is obtained as a product. 3 mole of glyoxal is obtained as a product. So the number of products indicate the type of alkene present in the compound. Suppose you will get only one product, then it's clear-cut indication that it is a one kind of, which kind of alkene? Yes, cyclic alkene. Two similar products then, or two same products then symmetrical alkene. Two different products then asymmetrical alkene. Now, if number of products clear is more or is not an aldehyde or ketone, or it is a dialdehyde or diketone, then it must be alkyne group must be present in that compound. We will study in detail about this functional group in the next lecture. Once again, we will go through the diagram. You cannot make a note on it. Ozonolysis.